Good evening, ma'am. This is K. Pranavi. My roll number is 234G1A0488. I am from ECE section, and my topic in this is P-type semiconductor. So, introduction to semiconductors. What are P-type semiconductors? Doping process, band structure, applications, advantages and disadvantages, future trends. So, introduction is in this presentation, we'll see about what are P-type semiconductors and how we dope them, and what are its applications, and how the trends are going about these P-type semiconductors in these days. So, introduction to semiconductors. Semiconductors are materials whose conductivity is between insulators and conductors, that is, conductivity is greater than insulators and less than conductors. That is, actually, semiconductors. Before going to the semiconductors, let us know about what are the insulators and conductors. Conductors means which possess the electricity. Insulator which doesn't possess electricity. Then what are semiconductors? Semiconductors are conductors which partially allows the current. That is, their conductivity is between conductors and insulators. That is, it is more than insulators and less than conductors. So there are two types of semiconductors, that is intrinsic and extrinsic. And intrinsic semiconductors are actually pure semiconductors, and extrinsic are doped by along with the pure semiconductors. So when we dope with the pure semiconductors, then we'll get two types of semiconductors, that is N-type and P-type. So in this N-type is the majority is electrons, and P is majority is holes. We'll see what are those. So what is p-type semiconductors? When a small amount of trivalent impurity is added to the pure crystal, the resulting crystal is of p-type semiconductors. That is, you know what is the main way of a trivalent atom, right? So when we take like boron atoms, they when we add them to a pure crystal, that is maybe silicon or germanium something. So this results the p-type semiconductors. That is let us consider a trivalent impurity like boron B is added to the pure semiconductor like Ge. Then the impurity atom occupies one of the positions of Ge atoms. The three valency electrons of borons are covalently bonded with three valence electrons of Ge, and there will be deficiency of electron is a hole. So we actually know that Ge contains four valency electrons, right? So when these three electrons in the boron is covalently bonded with the Ge, then electron deficiency will be there. So that is known as hole. Here, holes are majority carriers in p-type. So what is doping process? P-type doping involves adding impurities that created holes in the semiconductor lattice. These holes can move through the lattice, contributing to current flow. The electrons like boron and gallium has fewer valency electrons than the host conductor material. So this is all about how the doping process is happens in the p-type semiconductors. That is these holes will move through the lattice, which happens to be the current flow, and the elements like boron and gallium has fewer valency electrons. I mean, when compared to the Ge and boron, we know that boron has the few valency electrons. So the dopant atom accept electrons from the valency band of the semiconductors, creating a negative charge. So this resulting semiconductor is called p-type. These are essential for making devices such as transistors, diodes, and solar cells. So let's see how the band structure is in the p-type semiconductor. So the band structure consists of valence bond and conduction band separated by the Eg, that is energy above the valency band. So if there is a like the band structure actually valency band between valency band and the conduction band, there is the energy gap. that is denoted by the Eg. So, at room temperature under T greater than 0 Kelvin, the electrons from the valency band occupy the acceptor energy levels and gets ionized. If the temperature is further increased, then due to breakage of covalent bonds, entered into conduction band, leaving more holes in the valency band. Thus, holes are majority carriers and electrons are minority carriers. In p type, the Fermi energy level lies above the valency band. So, this is the pictorial representation of the band structure in the p type semiconductors. What are its applications? We know that p-type semiconductors are used in many ways. That is in solar cells, diodes, BJT, and temperature sensor and microchips. Here are the few examples and see how it works in them. Like in solar cells, p-type semiconductors are used to flow the like positive layer of a solar cell, which absorbs the and generates electron hole pairs. So in diodes, p-type semiconductors are used to form one side of the PN junction, which is device that allows the current to flow in one direction only. So like this, in BJT also, p-type semiconductors are used to form the base and emitter or the collector of the uh, BJT, that is bipolar junction transistor, which helps in amplifies or switching electrical signals. Temperature sensors. P-type semiconductors are used to measure temperature changes by detecting the variation in the electrical resistance. Advantages and disadvantages. Advantages. They have low humidity dependence on. So these are the few advantages and disadvantages of P-type semiconductors. That is, they have higher catalytic effect than N-type, and they can enhance the reaction rate of gas molecules on their surface. These are the advantages of P-type, and disadvantages are they have lower mobility than N-type semiconductors, which means they have lower speed and performance, and also they have higher contact resistance than N-type semiconductors, which means they have high power loss and heat generation. So, what are the future trends of the p-type semiconductors? So, as you know that day by day the world goes on, there are new things that come to the new world. Like we develop them and we enhance them. So, these are the few future trends of the p-type semiconductors, that is p-type two-dimensional semiconductors, p-type metal oxide semiconductors, p-type organic semiconductors. These are the things that scientists came up with the new things to this world. Like maybe in future we'll get to see more about the in more fields of like more of electronics and automated new discoveries in this field. So let us see what is p-type new. So these are different, like in P-type metal oxide semiconductor, metal oxides are class of materials that have band gaps, high chemical stability, and abundant resources. Likewise, organic has composed of carbon-based molecules that have low cost, lightweight, and easily processability. So these are the future trends of the P-type semiconductors. So, in this, we learned about the what are pH semiconductors and how we dope them, and what is its band structure, and what are the applications of it, and what are the future trends of semiconductors, this P-type semiconductors. So, we learned about in this presentation. Thank you.